Okay. For what value of c is the function defined by blah 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 continuous at x equals -1? Continuous. What is the continue? What does it mean to be continuous? Well, let's talk about that. This is introducing this with an example, huh? Okay. Write that down though. Okay. Alright, so for a function to be continuous at x equals a, so at some x value, for it to be continuous at some x value, the two-sided limit must exist, meaning the limit from the left has to go to a certain number, and then the limit from the right has to go to that same number. Ooh. And when you plug in f of a, or when you plug in a to f, that value, whatever the output, has to agree with the limits. Must agree with the two-sided limit, okay? Let's write down the notation for it, alright? That's the definition for a function to be continuous. Let's write down the notation. So f of x is continuous at x equals a if the limit from the left equals some number L, the limit from the right is equal to some number L, and f of a, when you actually plug it in, you also get L. So these all have to be the same. That's same, not sane. Okay, yeah, that's the definition. Those are the three conditions. Maybe I'll put bullet points. Those are the three conditions that must be satisfied for a function to be continuous. If you're checking to see, or you're saying like, oh, it is continuous at -1, find the c value, then that means for that function we have to take some limit as x approaches some value from the left, as x approaches some value from the right, and we have to plug in that value and see if we get all three, in all three cases, the same thing. Okay. What else? Let's take a look at some examples of discontinuous things. And I'll show you how they apply to these rules. We're going to take a look at pictures. Okay, pictures. So here, if we take a look at this function, we can see that it's discontinuous here, meaning like you can't draw this without picking up your pen. There's a hole in it. Oh my goodness, dear Liza, dear Elijah, dear Liza, what? So this, let's see which rule it violates. If we take the limit as x approaches a from the left side, that's some y value. That actually has a limit. That limit exists. If we take the limit as x approaches a from the right side, that limit also exists. So number 1 and number 2 are good. However, if we were to plug in a, there is no definition. There is no y value for that. So this third condition is not satisfied. So that's why it's discontinuous. Okay, so that's it. Same if we had like a point out here. Still, the limit as we approach from the left side and the right side is this y value, whatever this is. And it's different. That's different than this y value when you actually plug in a. So this third condition still would not be met. Okay, so that's what happens there. Let's look at another discontinuous example. So in this example, this is definitely discontinuous because there's a huge break, there's a huge jump in our function. But from our conditions standpoint, well, let's see. The limit from the left side, okay, that exists. That's some y value there. I don't know what that is, but that's some y value. And then the limit from the right side is whatever this y value is. Remember, the limit is whatever your y value approaches as you approach a certain x value. If we were approaching a, the one-sided limits would exist. However, they're not the same. They disagree. They disagree here. So, yeah, I mean, these all three have to be the same thing. If I were to plug in a, Well, I plug in A. There's nothing here, so it's not. F of A would not be this. The y value from when I plug in A would not be this. It would have to be this. So really, this and this agree, but this one is not. That one doesn't work out. So this is a discontinuous function because it doesn't satisfy this condition. All right. Well, let's see if I can think of another example. So on this one, actually, all three of the conditions aren't satisfied because the limit from the left side has to be a number. Here, if we take the limit from the left side, we're approaching positive infinity because there's an asymptote here. So this doesn't even get satisfied because it has to be a number. Infinity is not a number. Same with the right side; it has to be a number. This approaches positive infinity, so that doesn't work. And then when we plug in A, we actually don't have a y value. It's not defined. So all three of these don't work out because this is not. I mean, these agree, but they're not a number. It has to be a number.